Hello and welcome to INE. So today in this webinar we are going to be talking about OSPF Stubby Areas, Totally Stub, Not So Stubby Area and Totally Not So Stubby Area. Before we start this webinar, I just want to have a quick introduction. So first of all, I'd like to thank you guys for attending this webinar. And my name is Rohit Pardasani, and I am a full-time instructor with INE. I have 5 CCIs: CCI in Route Switch, Security, Voice, Collaboration, and Service Provider. So without wasting much time, let's quickly jump into OSPF Stubby Areas, Totally Stubby Areas, Not So Stubby Areas, and Totally Not So Stubby Areas. So what exactly we would be learning in this webinar? We would be basically focusing on LSA types. So again, LSA type it's kind of needed for you to know the different OSPF LSA types. You really need that because if you want to understand OSPF stubby areas or totally stubby areas, you really need to have at least some background knowledge of the different types of LSAs which can come inside the stubby areas or totally stubby areas. So we would be focusing on the LSA types. Again, it won't be really in-depth to a point where we are looking at a CCI level. It's just going to be introduction to the LSA types because our main focus is going to be on the stubby areas. So we would look at LSA types, and the next thing that we would look at is going to be stubby areas, configuring stubby areas, totally stubby areas, the differences between stubby and totally stub. Then we would look at not so stubby areas and then totally not so stubby areas. Again, this webinar is not just going to be theoretical concepts, it's also going to be a lab demonstration. So I would actually implement stubby areas, totally stubby areas, not so stubby areas, and totally not so stubby areas. And we would look at the logs, the debugs, and look at the database to see what do you actually learn or what routes are being basically learned in those areas. So let's quickly start off with the different types of LSAs. Now, as you know, in LSAs, OSPF has different types of LSAs. We have many LSAs, but our main focus in this webinar is going to be only on a few LSAs that I'm going to touch base on. So first of all, what exactly is an LSA? So as you know, OSPF uses LSDB, which is the link state database, and it fills this database with LSAs, which is link state advertisement. And instead of using LSA1 packet, OSPF has different types of LSAs. So it's not just one LSA. OSPF is not about just one LSA that I'm just going to send one type of LSA for all different types of routes. It's actually different types of LSAs that you would see in your link state database. So what we would focus on is going to be LSA1, which is called as the router LSA. We would look at LSA2, which is type 2, which is called as the network LSA. And then we would look at LSA3, which is called as the summary LSA. We would focus on LSA4, which is the ASBR summary LSA. And then LSA type 5, which is external LSA, basically the routes you learn from an ASBR. And then lastly, we would look at LSA7, which is basically not so stubby area LSAs. Again, it's basically NSSA external LSA. So these are the only LSAs that I would majorly focus on in this webinar. So what exactly is LSA1, which is router LSA? Now, router LSA is basically, it contains a lot of information. So every router which is running OSPF would be generating LSA1. LSA1 is only flooded within the area. It's something that cannot go outside the area. So if you did have multiple areas in your configuration, let's say if you were deploying a multi-area OSPF, then you would see LSA1, but this LSA1 does not cross the border. It's only within the area. So each router within the area will flood type 1 LSA within that area. And so what exactly does this LSA actually contain? Well, LSA1 contains prefix information. So every router, let's say if I have a router that has 3 interfaces and all those 3 interfaces are basically running OSPF. OSPF is basically activated. In that case, that router is going to generate LSA1, and that LSA1 would contain the 3 prefixes that he's advertising. So it's not that because I have 3 prefixes, I am going to advertise 3 LSAs. No, it's just one LSA. LSA1, one single LSA, which contains the list of links that is basically running OSPF. So that is LSA1. So it contains a list of all the prefixes that a router has. It also contains the cost of each of those links. So when I advertise a route to my neighbor, so when I'm advertising LSA1 as an update to my neighbor, when I'm advertising that, I will give you the list of all the links which is basically running OSPF. At the same time, I will also give you the cost of those links. So LSA1 also contains the cost. It also contains the neighbor's router ID. However, this actually depends on the type of network connectivity that you have between the 2 neighbors. For example, if you and me are running OSPF and you and me are basically running OSPF and our connectivity type is a point-to-point connection, which is maybe a WAN link, in that case, when I advertise the update LSA1 to you, I would insert the neighbor's router ID. So I would basically insert your neighbor ID in my update. So neighbor's router ID is there in the LSA1. However, if your connection to me, if you and me were neighbors in a broadcast network type, in that case, the neighbor's router ID information is basically lost. That information is only by the DR, which is basically LSA2. So if there was a broadcast segment, you would see LSA2. Otherwise, you would only see LSA1. You would not see LSA2. So if my connection to you is a broadcast segment, in that case, I don't send the update to you directly. I send the update to a DR, and the DR gives the update to you. So in that case, in that kind of an environment, you would see LSA2, which is network LSA. So if the network type is broadcast, instead of the neighbor router ID, you would see the IP address of the DR. So this is LSA1. So remember, LSA1 is prefix information. It contains a list of all the networks which I'm advertising to you, including the cost, including the neighbor's router ID. The neighbor router ID may change to the DR's IP address in case if it's a broadcast segment. So this was LSA1. The next one is basically LSA2. In LSA2, like I said, LSA2 only comes in when there is a broadcast segment. So when there's a DR present. So it's the DR who sends the update to everyone. LSA2 is not prefix information. It does not contain prefixes. It only contains router ID information of all the routers in that broadcast segment or broadcast domain. So let's say if there were 3 routers, me, you, and maybe one more router, we all are connected through a switch in one subnet, and we all are running OSPF. In that case, one of the router would be elected as the DR, the second router would be the BDR, and maybe the third router would be DR other. So if the DR other wants to give an update, he would give the update to the DR, and the DR would give it to everyone else. So the prefix information is still LSA1. LSA2 only contains the list of all the routers connected in that broadcast environment, which is basically 3 routers, you, me, and that third router. So the router ID information would be basically in LSA2. See, the thing is that with point-to-point, I see the neighbor's router ID. So I know, okay, this router connects to an X router. I have the neighbor's router ID in that information. But if it's a broadcast segment, router ID information is lost, and you need to basically look at LSA2 to find the router ID of the neighbor who is connected on that segment. So that information is in network LSA. It only contains router ID information. It does not contain prefix. It does not contain cost. Again, LSA2 is something which you would only find within the area. It cannot go outside the area. It cannot cross the border. So LSA1 and LSA2 is only contained within the area. So if I am advertising to my neighbor, that neighbor cannot give it outside the area. So LSA1 and 2 would not go outside the area. It's basically blocked. But if you look at LSA3, LSA3 was summary LSA. Summary LSA is a prefix information that is only generated by the ABR. Only the ABR can generate LSA3, which is basically containing the list of networks which he's learned through LSA1. So for example, if you look at this diagram here, I have router A who is basically advertising 1111 to his neighbor. Now, which LSA would he send as a prefix information to router B? That would be LSA1, because only LSA1 is prefix information. Would there be a LSA2 in that area too? Would there be LSA2? Maybe yes, maybe not. That really depends on how the two routers, A and B, how they are actually connected with each other. So if they are connected through a broadcast segment, if my network type is a broadcast, in that case, yes, there would be LSA2 also besides LSA1. So router A would not give the LSA1 update directly to router B. Instead, router A would give it to a DR, and the DR would give it to router B. Again, I may be the DR and a normal router. So it's not, don't think of DR as a separate router, or maybe like a router which you've designated as a DR. It's a virtual kind of system. So, but think of it as a separate router virtually. So let's say if B was the DR, A does not give it to B, the router. A gives it to B, the DR, and the DR gives it to B. So if it's a broadcast segment, yes, you would see LSA2 also. But prefix would be LSA1. Now when that update, which is 1111, when that route reaches router B, he cannot send that update to router C as LSA1, because the rule says that LSA1 update cannot go outside the border. So what does our router B do? What he does is he blocks LSA1, he blocks LSA2, and now he generates a new LSA, which is LSA3, summary LSA. Now again, this name is kind of confusing because you would think that summary LSA means summarization. It has nothing to do with summarization. Though with multi-area, you have support for summarization, because with single area, I really cannot do summarization. So that's kind of the limitation of single area. With multi-area, you can do summarization. So if you look at this diagram, LSA1, let's say if all the links between all the routers were point to point. So there's no DR, there's no LSA2 at all, because all the links are point to point. So router A would send LSA1 advertisement which contains the list of prefixes, which he has. He sends that to router B. As soon as router B gets that, he blocks LSA1, generates a new LSA for the prefix. Now see, there's a difference. In LSA1, it was one single LSA which contains the list of prefixes. So let's say if R1 was advertising 4 networks, so he would send one single LSA, LSA1, which contains 4 links. But when our router B gets that, what he does, he blocks LSA1, and now he generates a new LSA, which is LSA3. And he would generate one LSA3 per link. So if there were 4 routes coming from router 1, router B would send 4 LSA3 updates to area 0. Now, as you know, the rule of OSPF is that everybody within the area needs to maintain the exact same copy of the database. So router C gets that. He sees that a new update has come in for 1111, and the advertising router is router B. He sees that. He does not know anything about router A. Router C would not know anything about router A, because router A's LSA did not reach router C. Router B was basically blocking type 1 and sending type 3, with him being the originator or the advertising router of that LSA. So router C gets that, and everybody in area 0 would see that the advertising router for 1111 is router B. So if I want to get to that network, I need to reach router B. Now what happens next? Router C needs to now send that update to router D. But because the border is changing from area 0 to area 1, router C will modify the LSA. He would modify LSA 3, insert himself as the advertising router, and then advertise LSA 3 again to area 1. So now everybody in area 1, they don't know anything about router B. They don't know anything about that. For them, the advertising router is router C. See, think of the ABR like maybe an airport, you know? So it's something like that. Let's say if I was in New York, and let's say if I'm sitting at home and I need to reach maybe Las Vegas, right? So I need to reach there. So what's going to happen is that I don't really need to run SPF. See, the whole point of multi-area was to reduce the SPF calculation, because if this whole thing was one single area, router D would see the advertising router as router A. So think of area 1 as maybe New York, and I am router D. I am sitting in my house and I need to reach Las Vegas, which is maybe area 2. I need to reach there. If this was one single area, I would see the advertising router as router A and not router C, because in single area, everybody needs to maintain the exact same copy of the database. It can't change. So nobody can change the advertising router. So as me sitting in New York, if I need to reach Vegas, I would need to find the best path to reach Vegas. Now, how many ways can I reach Vegas? I could fly, or I could drive all the way there. There would be thousands of ways to get to Las Vegas. And that really becomes a problem from SPF perspective, because the convergence would be affected, and it would take a lot of time for me to find the best possible path to reach Las Vegas from New York. But now when I have multi-areas and router C is changing the LSA 3 to himself as the advertising router, what's going to happen? I'm sitting at home, I need to reach Las Vegas, and I don't need to find how much is it going to cost me to reach Las Vegas. What I see is, I'm sitting at home, I see a big billboard, maybe an advertisement from American Airlines, which says, hey, we have a direct flight from JFK, which is router C. Think of the ABR as an airport. So we have a direct flight from router C to router B, which is the airport of Vegas. And from there, we would have a limousine waiting for you. They would pick you up from the airport, take you to the Las Vegas Strip, maybe to MGM, wherever you want to go. So I don't really need to find out how much fuel do you think the plane or American Airlines is going to spend to fly from New York to Las Vegas. I don't need to think about that. What would I do? If I'm sitting at home in New York and I see a billboard of American Airlines which says, okay, to reach Las Vegas destination MGM, to reach there, I have an all-in-one inclusive cost, which is the SPF of router C. I have an all-in-one inclusive cost of maybe let's say $5. Let's keep it as $500, just to be realistic. So let's say $500. So I don't need to calculate what's the cost of the flight to reach Vegas? How much is he paying to Uber to reach MGM? How much is he paying for a meal in MGM? I don't really care about that. The billboard says, come to JFK. From there, we have a flight which goes to Vegas. From there, we have a limousine to take you to MGM. From there, we have a reservation, all-inclusive dinner package for you, and that is $500. So what do? All I do is book an Uber to JFK, which is router C. Add the cost, $500 plus my Uber cost to the airport. That becomes my total cost to reach that destination. So multi-area really helps a lot in reducing SPF because I don't need to run SPF to destination. Instead, I run SPF to just the ABR. So if you look at this diagram, LSA1 update comes in within area 2, then the ABR of area 2, which is router B, blocks that, generates LSA3 with himself being the advertising router, and everybody in area 0 would see router B as the advertising router. When it crosses the border again, router C would modify and put himself as the advertising router along with his SPF and then advertise to area 1. So everybody in area 1 knows if I need to get to Vegas, I need to take an American Airlines flight from JFK, which is router C. All I do is run the SPF to the ABR and I get my best path cost. So this is LSA 3, which is prefix information of inter-area. It is represented in the routing table as OIA. The next one is LSA 4. LSA 4 is ASBR summary LSA. Now again, LSA 4 is not prefix information. It is router ID information of the ASBR. So the minute there is an ASBR present in your OSPF domain, for example, if you look at this diagram, I have router A, which has a RIP domain somewhere, though nowadays nobody uses RIP. But let's say if there was, maybe RIP or EIGRP. So router A in this diagram has RIP running somewhere, and he is redistributing those routes in OSPF. So the minute he redistributes, he becomes an ASBR. And now he would start generating LSA 5. LSA 5 is prefix information. LSA 4 is not prefix information. So what's going to happen is that router A is sending LSA 5. Router A is not sending LSA 4. Remember, LSA 4 does not come from the ASBR. Only an ABR can generate LSA 4. So LSA 5 is being generated by router A. He sends that, he floods that throughout the OSPF domain. As soon as the ABR gets to know that, okay, I have received an LSA 5 external LSA update, router B, who's the ABR, he generates LSA 4 summary, ASBR summary LSA and floods that to area 0. And then router C modifies that to himself being the router ID as the advertising router and then forwards that to router D. So if you look at this diagram, I have type 1 LSA being received. Now why type 1? In fact, I just said sometime back it was type 5. So how does it actually work? See, what's going to happen is that the minute I give the redistribution command on router A would send his prefixes, RIP updates or RIP routes, which go into OSPF. Those updates are sent as LSA 5. So LSA 5 goes unchanged throughout the OSPF domain. I'm not really talking about LSA 5. But how does router B know that router A is an ASBR? How does he know that? So what happens is that the minute I do redistribution, router A would basically set a bit. He would turn on a bit, which is basically, he basically flips a bit to let the ABR know that I am an ASBR. And this happens in LSA 1. So the minute router B receives LSA1 updates, normal OSPF updates, not external routes, normal OSPF updates, he sees that in the update, in the LSA1, a bit is flipped, which basically means that router A is an ASBR. That's how B knows that, okay, he is an ASBR because his bit is flipped. So when B gets to know that, he generates LSA4, ASBR summary LSA. Remember, ASBR summary LSA is not an update. It is router ID of the ASBR. That's why if you look at this diagram, I have type 1 LSA coming from router A to router B. I'm not talking about the prefix of RIP right now. What I'm talking about is the minute I do redistribution, when router A is sending his OSPF routes, not external, his normal OSPF routes, he flips the bit just to let the ABR know that I am also an ASBR. That's why router B generates type 4 ASBR summary LSA, which contains the router ID information of the ASBR, which is router A. When it gets to C, C modifies that LSA4 and puts himself as the advertising router to let area 1 know that there is an ASBR present in our OSPF domain. So that is LSA4. And then we have LSA5, like I discussed. LSA5 was exact prefix information. Prefix information learned through redistribution. That comes from the ASBR. So LSA5 is a prefix. A quick way to actually remember this is all the odd ones, odd LSAs, LSA1, LSA3, LSA5, LSA7. They are all prefix information, updates. LSA2 is not a prefix information. LSA2 is router ID of all the routers in that broadcast segment when there's a DR present. And LSA4 is the router ID of ASBR. All the odd ones, 1, 3, 5, 7, they are prefix information. So here I have LSA5. This comes from the ASBR and that does not change. That goes unchanged throughout the OSPF domain by the ASBR. So ASBR advertises that throughout the OSPF domain and it does not change at the border. Every router in every area would see router A as the advertising router for those RIP routes. Again, that really depends on if it was multi-area without, maybe without not so stubby, because in not so stubby something changes. But let's say if there was no not so stubby configuration, it was just normal multi-area configuration, in that case every router which is running OSPF would see router A as the advertising router for those external routes, which is learned through redistribution. That is type 5. And then the last one that we need to look at or focus on is going to be LSA 7. I mean, there are more LSAs, but again, we are not looking at that at this point of time in this webinar. So LSA 7 only gets generated when there is a not so stubby area configuration. So if you look at this diagram here, area 2, which has an ASBR, which is router A, area 2 has been configured with not so stubby, as not so stubby. So the minute router A redistributes from RIP to OSPF, normally he generates type 5 LSA, which is OE routes, either OE1 or OE2. Default is OE2. But he generates type 5 LSA. But if I configure area 2 as not so stubby, he would not generate LSA 5 because there's a rule for not so stubby that type 5 LSA cannot go inside not so stubby area. So instead, he generates type 7 LSA, which is not so stubby area LSA or external LSA for not so stubby. He generates type 7, which again is prefix information for the RIP routes learned through redistribution. So he generates type 7. Type 7 cannot go outside the area. Unlike type 5, which was flooded throughout the OSPF domain, type 7 is only within NSSA area. So as soon as router B gets a type 7 update, he blocks that. He blocks that, and instead he generates a type 5 LSA and floods that throughout the OSPF domain. So for outside areas, for example, area 0 or area 1, for them, the ASBR is not router A, the ASBR is router B. Now, why does router B generate type 5 LSA? He's not an ASBR. He's not doing redistribution. The reason he generates type 5 LSA because router A will instruct router B to generate a type 5. So this is done with the P bit. So the router A actually sets a P bit, which you can actually see in the database. If you actually look at the database, you would see that router A is setting the P bit, which basically means that translate the LSA 7 to LSA 5. Because not so stubby area LSA cannot go outside the area. If I cannot advertise that outside the area, how would other areas know about that update? So that's why the router A, which is the ASBR, which is the true ASBR, he sets the P bit, which tells router B that translate LSA 7 to LSA 5, and then send the update through OSPF domain. So this was LSA 7. So now that we know about the LSAs, let's now go and look at the stubby area, totally stubby area, not so stubby area, and also totally not so stubby area. So the first thing that we will look at is going to be stubby areas. Now the first thing that comes to our mind is everything is working fine. I have multi-area configured. Why do I need to configure stubby areas? What's the need for configuring stubby areas? See, the thing is that think about from perspective of why do we do multi-areas? Because with single area, I cannot do summarization, number one. And the number of LSAs would really drastically increase. And there would be too much SPF calculation as your topology increases. So we configure multi-area. Now, what if I had some routers which were lower end routers, maybe does not have enough CPU or enough memory, so it cannot handle 1000 routes. So I want to reduce the routing table. Imagine if I had 50 routes from external BGP being redistributed into OSPF. Maybe I had 50 more of RIP routes being redistributed in OSPF. Maybe I had 100 more routes of EIGRP being redistributed in OSPF. In that case, there would be 200 external routes going throughout the OSPF domain, which basically means that my routers need to process all those updates. So if I have lower end routers, maybe the CPU is not that big or strong, maybe the memory is low, or maybe the router is running at 90% utilization. So the CPU is always at 90% because it has to process so much updates. So what I could do is I could configure an area as stub. The minute I do that, the minute I configure an area as stub, that area would not receive type 5 LSA and would not receive type 4 LSA. So there are limitations of stubby areas. There are rules for stubby area. The first rule is that you cannot configure area 0 as stubby area. You cannot do that. You cannot have a virtual link going through a stubby area. And you cannot have an ASBR present in the stubby area. So based on these three rules, area 2 cannot be configured as stubby area. Why is that? Because I do have an ASBR in that area, which is router A. So I cannot configure area 2 as stubby area. Area 0 cannot be configured as stubby area. The only area we can configure as per this diagram is area 1. Area 1 I can configure as stubby areas. Let's say we did that. The command to configure stubby areas is just a single command, area, the area ID, and then stub. However, the stub flag must match for you to establish OSPF adjacency. So if you configure one router as stubby area with stubby area in an area, you have to configure all the routers in that area as stubby. Otherwise, you would not establish OSPF adjacency. You would not establish. So if you look at this diagram here, I have router A, which is basically redistributing the routes from RIP to OSPF, goes to B unchanged because it's LSA type 5. B sends to C unchanged. Once C gets it, C will block LSA 5 and C will not generate LSA 4. Instead, C would send a default route to area 1, because if he does not do that, then router D would not have any reachability to that external route. Because how was D reaching that external route? Because earlier he was getting external routes in his database and in his routing table. But now what's going to happen is that C, which is the ABR, as soon as he gets LSA 5, he blocks that. He does not generate LSA 4, or he does not send LSA 4 in area 1. Instead, he sends a default route to that area, which is a type 3 default route, so that those routers can still reach the external network. This is stubby area. So in stubby area, only type 5 and type 4 is blocked. That's the only thing which is blocked. The next thing that we have is totally stubby area. Totally stubby area is pretty similar to stubby areas. The rules are still the same, that you cannot configure area 0 as stubby area, or you cannot configure an area that has an ASBR, and you cannot have a virtual link. So the only area that I can configure as totally stub is going to be area 1. Again, stub flag must match. So if you configure stub on one router, you have to do that on all the routers. So when you configure totally stub, you are basically telling the ABR to not send type 3 LSA also. By default with stub, it blocks type 5 and 4. But when you configure totally stub, it blocks LSA 3 also, which means inter-area LSAs also gets blocked. So let's say a type 5 LSA was coming from ASBR and type 3 LSA was coming from router B, which is the ABR. Router C, as per the diagram, would basically block 5, 4, and 3, and instead he would send one default route, which would be a type 3 default route, summary LSA. So only one type 3 is allowed in the totally stubby area. So he has to use the default route to go to inter-area or even to get to external network. That is totally stub, where your routing table drastically reduces, which means the only LSAs that you would have in your database would be LSA1, intra-area prefixes, LSA2, DR information, and one type 3 LSA, which is the default route. This is totally stub. Now to configure totally stub, the command would be area1 stub, no summary. Now this command can only be done, or it should only be done on the ABR, because only the ABR generates LSA 3. On the other routers, you would just give the command area1 stub, but on the ABR, you would say area1 stub, no summary, which basically tells the ABR that besides blocking 5 and 4, don't send summary LSA, which means 5, 4, and 3 basically gets blocked into totally stubby area. The next one that we will look at is going to be not so stubby area. Now, not so stubby area is pretty similar to stubby area, with one limitation relaxed, which is you can have an ASBR in the not so stubby area. So The other limitations, like you cannot have a virtual link, that still exist. So when you configure an area as not so stubby, you cannot have a virtual link going through it. And you cannot configure area 0 as not so stubby. You can have an ASBR. So if you look at this diagram, I have area 1, which is configured as not so stubby. Now, even though area 1 has an ASBR, I have router D, which has EIGRP connected, and EIGRP is being redistributed in my OSPF. So router D becomes the ASBR, but because this area is configured as not so stubby, the router D would not generate type 5 LSA. Let me in fact tell you what's happened. Now if you look at this diagram carefully, I have two ASBR. One ASBR is in area 2 outside the NSSA area. It's in area 2, which is router A, and one ASBR is router D, which is inside the NSSA area. Let's talk about the routes coming from outside, which means routes being redistributed on router A. How would those routes be seen in the not so stubby area? So router A would, when he redistributes, he would send LSA 5. LSA 5 goes throughout the OSPF domain. Once it reaches router C would block LSA 5 and would not generate LSA 4 towards area 1. So LSA 5 and 4 basically gets blocked going into area 1. So would router D be able to reach the route of router A? No. You know why? That's the main difference between stub and not so stubby. In stub, the ABR blocked 5 and 4 but sent a default route as type 3. In not so stubby, the ABR blocks 5 and 4 coming into the area but does not generate a default route as type 3. It does not do that. For you to tell the ABR to generate a default route, you have to give an additional command, which is area 1 NSSA default information originate. When you give that command, the ABR router C will generate a default route, and this default route would not be a type 3 default route. It would be a type 7 default route. So if you look at this diagram, the green line, the green arrow, so it's coming from router A, type 5, reaches router C, gets blocked, 5 and 4 gets blocked, and then router C generates type 7 default route towards the NSSA area. That's why router D would be able to reach RIP routes of router A using that default route. But this default route does not come automatically. You have to give the command default information originate under NSSA. So the command is area 1 NSSA default information originate. That's one part of it. What about the routes of router D, the EIGRP routes? Now, the rule of NSSA is that you can have an ASBR. However, type 5 LSA cannot be generated. So what's going to happen is that router D, when he redistributes EIGRP into OSPF, instead of generating type 5, he generates type 7. And type 7 is only within the NSSA area. So it goes to everyone in area 1. As soon as router C, who's the ABR, gets type 7, he also sees a flag being turned on, which is translate 7 to 5. So router C translates the LSA 7 to LSA 5 and sends LSA 5 to outside to everyone in the other areas throughout the OSPF domain unchanged. So if you look at the type 7 coming from router D, reaches router C blocks type 7 and sends type 5 throughout OSPF domain. This is NSSA. The next one that we have to look at is the last one, which is totally not so stubby. Totally not so stubby is a lot like Totally-Stub. it blocks 5, 4, and 3, LSA 5, LSA 4, and LSA 3 coming into the area. So again, if you look at this diagram, let's talk about the routes coming from RIP, router A, through OSPF. So router A sends type 5 LSA throughout the OSPF domain. Besides that, I have inter-area OSPF routes coming from the ABR. So LSA 5 and LSA 3 prefix information is coming to to router C, which is the third router, ABR. When he gets that, he blocks LSA 5, he blocks LSA 4, and he blocks LSA 3 going into the NSSA area. So will router D be able to reach the external route? Will he be able to reach inter-area routes? The answer is yes. The reason he's able to reach that external network or even inter-area, because in Totally Not So Stubby, the ABR generates a default route automatically. I don't have to give the command default information originate. It generates that default route automatically like Totally-Stub, and it's a type 3 default route. So if you look at the diagram again, 5 came from outside, 3 came from outside, got blocked, and then our router C generates a default route of type 3 automatically. That's why router D would be able to reach RIP routes of A and also inter-area routes. What about the routes of EIGRP on router D? That part is the same like Not So Stubby. Type 7 LSA is generated, not type 5, because type 5 cannot go inside Not So Stubby. So router D, who's the ASBR, instead of generating type 5, he generates type 7 that goes throughout the NSSA area, and when the ABR gets it, he translates 7 to 5 and sends type 5 throughout the OSPF domain outside of the NSSA area. This is totally Not So Stubby. So what we are going to do now is I will show you a diagram. We will actually implement all of this. We will test all of this, and we will confirm if those LSAs are being blocked. So let's do that. Let's actually lab it up and see how we can configure first stub, then we will modify it to do totally stub, then we will do not so stubby, and then we will do totally not so stubby. So let me quickly show you my diagram, which is pre-configured with OSPF. What I've done is, not to waste time for this webinar, I have pre-configured OSPF throughout my topology. I have pre-configured that, and it's multi-area topology. And I haven't configured stub or totally stub or not so stubby or totally not so stubby. I have not configured that. I've only configured multi-area. So based on that, we will actually test all of these 4 features of OSPF. Alright, so here is my topology, which is pre-configured with multi-area OSPF. Let me quickly show you what's configured. So I have area 0, which is here. That's my area 0, which is here. I have area 1, which is here. And then this is area 2. And here is where I have area 3. Now, all of these routers are basically pre-configured. I have all the routes in my routing table, and I have full connectivity. I have not configured any stubby or totally stubby or not so stubby. So what I'm going to do first is, let's in fact make router 9, which is in area 2, let's make him into an ASBR. So what I'm going to do is, I'm going to create some routes first. I'm going to create some loopbacks, and let's redistribute those loopbacks in OSPF. So let's start that off. So what I'm going to do is go to my router, and on router 9, let's create some loopbacks. So config T, interface loopback 9. Let's give the IP address as 99.99.99.99. 255, 255, 255, 255. Let's also create one more loopback, let's say 199, and give the IP address as 199, 199, 199, 199, 255, 255, 255, 255. So I have these two loopbacks, and I will go to my OSPF. Let's change my router ID to be 9999, and let's redistribute connected subnets. So once I redistribute these routes, these two routes would be redistributed in OSPF, and since I did not specify the metric type, the default metric type would be E2 routes. So throughout my OSPF domain, I should see these routes. Let me in fact quickly show you the routes in the routing table and also in my database. If you remember, I told you that LSA 5 was advertised by the ASBR throughout the OSPF domain, and it remains unchanged. So if I go to router 9 and do a show IP OSPF database external self-originate, you would see that router 9 is advertising 99, 99, 99, 99 in OSPF. His router ID right now is 151.99. I did change the router ID, but because I did not restart my OSPF process, my router ID would still be the old one. So anytime you change your router ID, you should go and restart your OSPF process. Let's quickly do that. Clear IP OSPF process, and let's say yes. Now once I do this, and if I go back to show IP OSPF database external self-originate, R9, who is now the ASBR, he is advertising LSA 5, and that LSA 5 would remain unchanged throughout the OSPF domain. So if I check here now, he is advertising 99 and 199 as a prefix. So two LSAs, 1499, 14199, and the advertising router is 9999. If I look at my checksum value, it's 0xFCF1. And if I go to router 10, if I look at the diagram, R9 is here, and R10 is at the other end, which is in area 3. So if I go back to R10 and do a show IP route OSPF first, I see the routes in my routing table as E2 routes, which you can see here and even here for 99 and 199. So it is in my routing table as E2 because default metric type is 2. And if I look at my database, show IP OSPF database external, you would see that the checksum value for 99 is FCF1, which is the same which R9 had advertised. So this basically proves that the LSA 5 remains unchanged throughout the OSPF domain. Now the problem is, how do I get to this network? I always do an SPF towards the advertising router. What's my SPF? What's my advertising router? It's 9999. Is that a prefix? No. It's a router ID of R9. So how do I get to the ASBR? To reach the ASBR, I look at the LSA4 show IP OSPF database ASBR summary. You would see that to reach this router ID, which is the ASBR, I should go to my airport or my local ABR, which is R5. So if I look at the diagram again, for R10, the local ABR is router 5, which is the ABR. So ABR gets that LSA, he generates that LSA and sends that down to other areas. So R5 is the advertising router. So again, not going into the LSA types in detail, we would quickly move forward with stubby areas. Now, if you remember, what was stubby areas doing? It was blocking type 5 LSA and type 4 LSA going into the area. But can they still reach the external network? Yes, because the ABR generates a type 3 default route. So let's do one thing. Let's configure area 3 as stubby area. Okay, so we will configure this area here as stubby. Let me in fact write it down for you. So we will go back to our router and we will configure all of these routers in area 3 as stubby area. Now again, if you remember, for configuring stub, my stub flag must be the same. Since my stub flag has to be the same, I have to configure all the three routers in area 3, R5, the ABR, R8 and R10. So let's go and configure that. As of right now, they all have external routes in their routing table. Let me go and do a show run section router OSPF, or in fact show IP route OSPF include OE routes. So I have 2 OE routes in my routing table as of right now. And I see LSA 5 also, I see LSA 4 also in my database. Now if I want to reduce my routing table, at the same time I want to reduce my processing of the LSAs, so I can configure this area as stub. Let's do that. So I will start with router 10, where I would go and say config t router OSPF 1, if I can spell that right, router OSPF 1, and here I would say area 3 would be stub. Now the minute I do this, you would see that I lose my neighborship with router 8. The reason I lose the neighborship is because the stub flag must match. So if I go back to 8 and do a show IP OSPF neighbor, you would see that my neighborship with router 10 is going to go down in about 13 seconds more. And my neighborship would not form with R10. In fact, if I do a debug IP OSPF, maybe I think adjacency, should probably show me that I have an issue of stub flag mismatch. If it doesn't show you here, you can probably give the command IP show IP OSPF, debug IP OSPF, hellos. In fact, it should show you here also. So I should see a message that I received a packet or a hello packet from R10, but mismatched stub flag. Like I said, when you configure stubby area, you have to configure the entire area, all the routers in that area as stub area. You cannot configure area 0 as stub. You cannot have a virtual link going through it. And you cannot configure an area as stub if there's an ASBR present. So I have to go and configure this on all my routers. So on R8 also, router OSPF 1, area 3 as stub. And lastly would be R5, where I would do the same thing, router OSPF 1, and area 3 as stub. The minute I do this, you would now see that R5, who's the ABR, he would block type 5 LSA and block type 4 LSA going into area 3. Let's quickly verify that. So if I look at R5, who's the ABR, if I look at his database, show IP OSPF database external, he has type 5. Why does he have type 5? He's getting type 5 from here. Basically, 5 is coming from 9, going to 7, 3, and then coming to 5. 5 is going to block it, and he will not send 5. He would not send LSA 5 and 4 down. Let's quickly verify that. So let's go back to our router and look at maybe R10's database. Show IP OSPF database external. If I look at his external database, he has no type 5 LSAs. It's completely blank. And if I do a show IP OSPF database ASBR summary, which is LSA 4, he does not have LSA 4 also. Now, it kind of makes sense because why do we use LSA 4? To reach the router ID of the ASBR. If I'm not giving you external routes, what's the point of me giving you type 4 LSA? That's why in stubby areas, LSA 5 and LSA 4, they both are blocked. 5 blocks the prefixes and 4 is not generated because you don't need to reach those prefixes. So I don't need to generate LSA 4 also. So 5 and 4 is blocked. Does that mean that the routers in the stubby area, can they reach that external network? Let's do a ping. So ping to 99, 99, 99, 99. Can they reach the external network? Yes. Why is that? If I look at my routing table, you would see that a default route got generated automatically. I did not generate this. Let's look at the database. Who generated this default route? Show IP OSPF database summary 0000. Why am I giving summary? because this route shows up as OIA, OSPF Inter-Area. If you remember from the slides that the ABR blocks 5 and 4 and automatically generates a type 3 default route. So if I look at show IP OSPF database summary for the route 0000, you would see, in fact, that's a lot of zeros. So 0000, you would see that the default route was generated by the ABR R5. So he generates the default route. And now what's happened with stubby area is that my routing table has drastically reduced and my database has also drastically reduced because I don't need to process external LSAs. I don't need to process ASBR LSAs. I don't have to do that. So I'm only concerned with one default route to reach all destinations. I still have inter-area routes. So if I look at my database, show IP OSPF database, let's do a show IP OSPF database router LSA. I still have LSA 1, which is intra-area routes. And I should have LSA 2 also because my connectivity between R8 and R10 is a broadcast environment. I did not change it to point-to-point. So I should see network LSA also, which I do. And if I do a show IP OSPF database summary, I have LSA 3 also. I just don't have LSA 4 and LSA 5. So my routing table drastically shortens or reduces, and my database also reduces. That's the advantage of using stubby areas. Now let's say if you wanted to reduce your routing table even further, maybe I don't want so many routes, maybe I have 1,000 inter-area routes. I don't want all the inter-area routes. I just want a default route just to go out of the area. Why should I maintain inter-area routes and LSAs also? So I can reduce that also by configuring Totally Stub. Now to configure Totally Stub, what you should do is configure stub first, configure all the routers in the area as stub, and then go to the ABR, which is R5, tell him that besides blocking 5 and 4 because of stub, you're blocking 5 and 4. Besides that, also block LSA 3. So for that, all I would do is go to router OSPF 1 and say area 3 stub no summary. So once I say no summary, what you're effectively telling R5 that block 5 and 4 and also block summary LSA. So don't send summary LSA. So with this, if I look at the routing table of R10 now, show IP route OSPF, you would see that his routing table has drastically reduced. How many routes do I have? Now look at the routing table before. Before I configured this, if you look at my routing table, let's scroll back up. We had a lot of routes. If you see, I had so many inter-area routes, and before configuring stub, I had so many external routes also. So with you configuring Totally Stub, all I have now is a few routes, which is my intra-area routes. So maybe 5, 6, 10 routes, intra-area routes, and I have one inter-area route, the default route, which is automatically generated in Totally Stub. Like I said earlier, that Totally Stub blocks LSA 5, LSA 4, and LSA 3, and the ABR will generate one LSA 3, which is the default route. So the only summary LSA which is allowed in Totally Stub is the default route. So this is Totally Stub. Now, what is the problem with Totally Stub or stub? The problem is that for this area to go anywhere, let's say if it has to go to inter-area or if it has to go to the internet. So for all destinations, this area would have to go all the way from 10 to 8 to 5 and then go wherever he has to go. It has to exit from R5. The problem with Stubby and Totally Stub is that what if R10 had a connection to an ISP through the internet? So maybe he had another ISP connected there and maybe he wanted to go out to internet directly. Maybe there's an ASBR present. So the problem with stub and totally stub is that I cannot have an ASBR present in the stubby or totally stubby areas. That limitation was reduced or eliminated. So that was eliminated in not so stubby and totally not so stubby. So in not so stubby and totally not so stubby, basically you can have an ASBR. But one difference, you will not generate LSA5 as an ASBR within the NSSA area. Instead, you will generate LSA7. Let me in fact show you that. To demonstrate that, what I will do is we will configure one more ASBR. You remember in my slide, I had one ASBR which was outside the NSSA area, and I had one more ASBR inside the NSSA area. What we'll do is we will configure router 4 as the ASBR which is outside the NSSA area. So this is still totally stub. What we will do is, since we have an ASBR here also, this is also an ASBR, we will configure area 2 as not so stubby. So what's going to happen? R9, which was earlier generating LSA5, this time he will not generate LSA5 because he knows now I connect to a not so stubby area. I cannot send LSA5 there. So instead, he generates LSA7 and sets a flag which tells the ABR to translate 7 to 5. Now, who's the ABR for area 2? Only R3. R3 is the ABR. R6 is not an ABR because for you to be an ABR, you need to be connected to an area 0. R6 connects to area 1 and connects to area 2, but he does not connect to area 0. So R6 is not an ABR, only R3 is an ABR. So when 9 generates LSA7, he sets a flag which says translate LSA7 to 5. So R3 will translate LSA7 to 5 and send that. And LSA5 goes unchanged throughout the OSPF domain. So basically from here till here, I would see LSA7. Then it gets blocked here and then R3 generates LSA5, and that 5 will remain unchanged throughout the OSPF domain. Let's see that. And we will also see this ASBR, his routes, when it comes to the ABR blocks. If you remember, even not so stubby is like stubby area, so it blocks 5 and 4 going into the area. Let's in fact see that. So the first thing what we will do is we will just work on this. I will go to router 9, and in fact I'll go to area 2 and configure that as not so stubby. So as of right now, R9, who is the ASBR, show IP OSPF database external self-originate, he is generating LSA5 at this point of time. 2 LSA5 updates, one for 99 prefix, one for 199. So now I will go to config T, router OSPF1 and say area to NSSA. Again, the stub flag must match. NSSA is also a stub. It's not so stub, but it's still considered as stub. So my neighborship would go down because stub flag must match. So I have to configure all the routers in that area as not so stubby. So R7 would also be area to not so stubby. And R6 would also be not so stubby, router OSPF1, area 2 not so stubby. And lastly, the ABR R3, router OSPF1, area 2 not so stubby. So now let's go to R9 and do a show IP OSPF database external self-originate. You remember earlier he was generating type 5 LSA. Is he generating that anymore? No, he's not doing that anymore. Why? Because when I redistribute, by default it generates type 5. Is type 5 allowed in stubby or totally stub or not so stubby? Is it allowed? No. So instead of generating 5, he generates LSA7, which you can see here, show IP OSPF database, NSSA external. So NSSA external, self-originate, you would see that he generates type 7 for 99 and 199. And if you look at the flag, look at this flag. This is the flag I was talking about, the P bit, which basically R9 is telling the ABR that, hey, you cannot send my prefixes. LSA7 cannot go outside the NSSA area. You cannot send my prefixes outside as steps as LSA7. You need to translate this from 7 to 5. So as soon as R3 gets the LSA7, he generates LSA5. Now, is R3 an ASBR? No, only an ASBR generates LSA5, right? But because R9 has set the flag to translate 7 to 5, R3 will generate LSA5. So show IP OSPF database external, self-originate. Now R3 is generating LSA5 for 99 and 199, and he is the advertising router. And this would remain same throughout my OSPF domain. Obviously, it won't go to this area, area 3, because that's configured as totally stub. But if I check on maybe, let's say R2, if I check on R2, you would see that show IP route OSPF. You would see I have external routes, E2 routes. And if I do a show IP OSPF database external, so IP OSPF database external, you would see that the advertising router is not R9, it is R3. So for the outside areas, they don't know R9, they know R3. R3 is the advertising router for the LSA5 update, and it's not R9 because LSA7 cannot go throughout the OSPF domain. It gets blocked and translation happens 7 to 5. So this was NSSA, but this was only one part where the ASBR inside the NSSA area is sending LSA7, that gets converted to 7 to 5, and then that goes throughout the OSPF domain. What about the ASBR routes from the outside of the NSSA area? Let's see that. So if I go to R4, let's make him into an ASBR. So on R4, let's create one loopback 44, interface loopback 44, and say IP address 44, 44, 44, 44, 255, 255, 255, 255. And let's go to router OSPF1 redistribute connected subnets. If I look at R2, R2 would have the 44 network, which if you see here, he has 44 in his database, type 5 LSA. Now R4 is not NSSA, it's a normal area. So he's an ASBR, so he generates type 5. And type 5 remains the same throughout the OSPF domain. However, once type 5 LSA comes from R4, so R4 is sending type 5 everywhere. So this is type 5, and once it reaches R3, R3 blocks that. He blocks 5, and he would not generate LSA4 into this area, so he blocks 4 also. Let's verify that. If I go to let's say R7, which is inside the NSSA area, and if I do a show IP OSPF database external, I have no external LSAs. Show IP OSPF database ASBR summary, I have no LSA4. Do you think he would be able to ping the routes of the external routes behind R4? Would he be able to ping that? In stub and totally stub, I was able to ping the external network. Let's see in not so stubby. So ping 44, 44, 44, 44. I am not able to ping. Why is that? If you remember, I told you that not so stubby is a bit different from stubby. It still blocks 5 and 4, but it does not generate a default route automatically. You have to give one command. You remember that command? I had told you that we had to give the command area to NSSA default information originate. I have to tell the ABR to generate a default route towards the NSSA area. Only then they can reach the external network, which is outside the NSSA. Let's do that. Let's go to the ABR and give the command route OSPF 1, area to NSSA, default information originate. Once I do that, on R7, if I do a ping, I should be able to ping, which I can. And again, if you remember, I told you that this default route is not a type 3 LSA default route. It is a type 7. So show IP, let's do a show IP route OSPF. Let's do include ON. You would see that I have a type 7. In fact, let's do a show IP route OSPF. I should see a type 7 default route, which is here. So it's not a type 3. Totally stub is type 3 automatically. ABR generates that automatically. Stub generates type 3 automatically. NSSA does not generate type 3, or he in fact does not generate any default route by default. You have to give the command area number, NSSA default information originate, and only then he would generate a default route, and that's not going to be type 3, it's going to be an LSA 7. This is not so stubby. Now let's do totally not so stubby. Totally not so stubby is a lot like totally stub. It blocks 543 coming into the area and generates a default route automatically. So I don't have to give default information originate. Your ASBR generates 7, which gets translated to 5 by the ABR. Let's see that. So all I have to do is go to R3, which is my ABR, and I will remove this command. I don't need this command anymore. And I will give area to NSSA no summary. So if I look at my OSPF config, I don't have the default information originate. I only have area to NSSA with no summary. What this basically means, if I look at 7, show IP OSPF database external, do I have type 5? No. Do I have type 4? No, it was blocked. Do I have type 3? Summary? No, I only have one type 3, which is the default route coming from R3. So it came automatically, and that's a type 3 LSA default route. So look at my routing table now. I have only the type 1 LSA intra-area routes. I have type 2 LSA for DR being present, and I have type 7 LSA within NSSA external routes, which is type 7 for NSSA. So what's basically happening is that my router, this is the ASBR, when he sends the routes, R3 blocks 5, 4, and 3 and sends here a default route 0.0.0.0, which is an OIA summary LSA default route. And this ASBR, who is redistributing, he sends LSA 7, which R3 will forward ahead as LSA 5. So 7 to 5 translation happens. So you see, configuring stubby areas or not so stubby areas, or even totally stub or totally not so stubby, is pretty straightforward. It's just one command, area ID and stub, or area ID as not so stubby, or you add the keyword no summary on the ABR, and that makes it totally stub or totally not so stubby. I hope this webinar was informative to you, and thank you for watching.